SpaceX loses another Starship in a big explosion during pre-launch testing. China performs a test of the launch escape system for its upcoming lunar spacecraft. We've got a bunch of space news from Europe, and Honda is now making reusable rockets? We'll have all that and more coming up this week in Spaceflight. We've got space news from all over the world this week, starting with a few stories from Asia. China performed a pad escape test with its upcoming Mengzhou crew capsule, and with that completed a key milestone in the country's crewed lunar exploration program. Mengzhou, which roughly translates to dream vessel, is China's next-generation crewed spacecraft. It's designed to carry up to 7 astronauts and comes in 2 variants. One is designed for the moon and plays a pivotal role in the country's lunar exploration program, where it'll be used in conjunction with the lunar lander. This version will launch on a Changzheng 10 rocket in its standard configuration with 3 stages and 2 side boosters. The other variant will replace the Shenzhou capsule that currently launches crew to the Tiangong space station. When flying this mission, Mengzhou will launch on a single-stick Changzheng 10A, which only features 2 stages. This week, Mengzhou performed its pad abort test at Site 95A at the Zhochuan Satellite Launch Center. On June 17th at 12:30 local time, the launch escape tower fired and lifted the capsule up into the air. The capsule then separated from the launch escape tower before descending under parachute. Just 2 minutes after lifting off, it then touched down, cushioned by airbags. Official sources declared the test a complete success. This test verified that the capsule and its crew can get away from the rocket safely in the event of an emergency at the pad. It's a very common test for new capsules, and all recent US crew capsules have performed the very same test. Orion did it in 2010, Crew Dragon in 2015, and Starliner in 2019. This week's test was the 3rd test flight for the Mengzhou program. In 2016, the maiden flight of the Changzheng 7 carried a subscale capsule, and in 2020, the inaugural Changzheng 5B tested a full-scale version to test re-entry, parachutes, and touchdown. According to Chinese state media, a second escape test is scheduled for later this year. This will test the abort capabilities at maximum aerodynamic pressure during launch, similar to SpaceX's Crew Dragon in-flight abort test from early 2020. But the Changzheng 10 isn't ready for flight yet, and likely won't be for a while, so it's unclear which rocket will fly this mission. Regardless, that's certainly a launch to look forward to. Honda hopped a rocket. Yep. The Japanese car maker's building rockets now, and this week it conducted a hop test. The test vehicle is only 6.3 meters tall, 85 centimeters in diameter, and masses just over 1,300 kilograms fully loaded. On the afternoon of June 17th, the rocket lifted off from the test site in Taiki on the Japanese island of Hokkaido. It climbed to an altitude of 271.4 meters before descending, and after nearly 57 seconds, it landed only 37 centimeters from its target location. That's pretty much a bullseye. This was the highest hop the vehicle has performed so far. The company's been conducting tests at the Taiki site since last year, performing engine tests and hover tests with the rocket. Honda started its space program in 2019 after some young engineers who wanted to build rockets made a proposal. The program aims to incorporate technology and expertise from its other divisions into rockets, and ultimately, the company wants to launch satellites. But for now, they're working towards a suborbital launch by 2029. This week's test is a great step towards reaching that goal, so congratulations on this massive success. Starship really can't catch a break, can it? This week, SpaceX suffered a major anomaly during testing of Ship 36, the ship that was meant to launch on Starship's 10th flight. Over the weekend, the ship rolled out to the Massey Outpost test site, located a few miles southwest of SpaceX's Starship production site in Starbase, Texas. On Monday, June 16th, the vehicle conducted a single-engine static fire test, simulating an in-space burn. An in-space burn that SpaceX has tried to perform on the past 3 flights, but has yet to successfully accomplish. The next expected step was for the ship to carry out a 6-engine static fire test, potentially for up to a minute in duration, in order to corroborate that the vehicle's systems were good to go for a launch. This kind of testing was performed on the previous ship, Ship 35, which flew on Starship's 9th flight, so it was something that folks like us at NSF were expecting to happen as part of the pre-launch test campaign. Ship 36's 6-engine static fire test, if it had happened would have happened pretty late at night. Teams had closed off the road to the test site at around 8 p.m. local time, but it took at least another 2 hours until signs of propellant load were evident. The propellant load on tests like the one expected that night typically sees the liquid oxygen tank fully loaded in order to add as much weight as possible to the vehicle, while keeping the methane tank loaded only to a minimum of about 10 to 15% capacity. Now, the reason why that's the case is because they don't need that much methane for a short test like this, and if something were to go wrong with that little amount of methane, the damage would be a lot less severe. And that was something that, unfortunately, we ended up finding out at about 11:01 p.m. local time when this happened. Now, at the time of the test, the ship's liquid oxygen tank was nearly full, and the methane tank was about as loaded as it would have been for the 6-engine static fire test. So this meant that the explosion happened close to the end of the propellant load sequence, which happens less than 10 minutes from the test. Very quickly, it became clear that the origin of the explosion came from a sudden burst in the nose cone section that then resulted in the rupture of the main tanks that caused the explosion that you just saw. This nose cone section contains not only the payload volume, but also a number of other systems. For example, right near the tip are the ship's header tanks used for short in-space burns and the landing burn. These tanks then have 2 transfer lines, one per tank, that go down to the main tank for use by the engines during said burns. Also in the nose cone volume are several composite overwrapped pressure vessels, or COPVs, that are used for many other systems within the ship. These are essentially metal bottles wrapped in carbon fiber that are used to store fluids at really high pressures, normally between 300 to 400 bars. In Starship, some of these are used to store high-pressure gaseous methane or gaseous oxygen that are used for the Raptor igniters. Others also store nitrogen for purging or starting up the Raptor pumps. Given that all of this hardware was located near the location where the initial burst happened, well, there were many possibilities as to the trigger. A header tank losing pressurization, a transfer tube breaking, a COPV bursting, all of that was possible, and in fact has already happened to SpaceX rockets in the past. And to no one's surprise, it was in fact, once again, the COPVs at fault for a SpaceX rocket blowing up. Elon confirmed a few hours after the explosion that the preliminary data suggested that one of the COPVs in the payload bay section had failed below its proven pressure. Now, as far as we're aware, this would be the first time that this has happened with Starship. Elon also indicated that this was the first time for this specific COPV design. Falcon 9 suffered 2 explosions early in its history, once during launch and another on the pad, also relating to COPVs. The first one occurred in June 2015 and happened during ascent on the CRS-7 mission. It was found to have been caused by a faulty strut that was holding one of the COPVs inside the Falcon 9 second stage. The second one happened in September of 2016 and occurred during propellant load of a Falcon 9 in preparation for the Amos 6 mission. In that case, it was a lot more complicated. Liquid oxygen seeped into buckles that had formed in the inner metal liner of the COPVs while at low pressures, and the cold temperatures in the bottle turned the oxygen into a solid. When the COPV was then pressurized to full pressure, the buckles disappeared, pressing the solid oxygen against the carbon fiber at high pressure, causing the explosion. Thankfully, since then, both COPV struts and the COPVs themselves have changed designs on Falcon 9. But now, COPVs are back to bite SpaceX's Starships. Just an hour and a half after the explosion took place, SpaceX posted a statement on X about the anomaly, and perhaps the most important information was that no one was injured and everyone was accounted for. Hardware can be replaced, but the same can't be said for people. SpaceX posted another update about the explosion on its website about 16 hours later, confirming that the ship was indeed being prepped for a 6-engine static fire test ahead of Starship's 10th flight, and the company confirmed the statement by Elon that the initial look at the data indicated a failure of a COPV containing nitrogen. One other important piece of information is that the COPVs used on Starship are different from those on Falcon, and there's no commonality. Of course, now the job for the teams will be to find out what caused that COPV failure, and more importantly, what will be the next steps after this. You know, it's a shame that this happened, and certainly painful for the SpaceX teams. Just hours before the test, the FAA Current Operations Plan Advisory, which is used by the ATC system, had Starship's 10th launch as occurring just next week on June 29th. We were really close to it actually launching. But perhaps the silver lining of this explosion is that at least it didn't happen with a fully fueled super heavy booster below it. I don't think we ever want to find out what that would look like. This was also the week of the Paris Air Show, and the European space industry took it as an opportunity to show off their work and sign some agreements. There's a lot to talk about, so we've compiled it all into one segment, starting with the Exploration Company. During the show, the company unveiled a half-scale model of their space capsule called Nix, but with a bit of an unexpected twist. The mock-up showed off the crew version of Nix. The Exploration Company has been working on Nix since its founding in 2021. The capsule's roughly the size of SpaceX's Dragon, and it's designed to launch atop any heavy-lift rocket from anywhere in the world. Up until now, they've only been focusing on the cargo variant. In fact, the company's second demonstrator vehicle is going into space very soon on SpaceX's Transporter 14 mission, which is expected to launch in the next few days. The company named this test Mission Possible, and it will help them to test and verify the technology for Nix. And the Exploration Company already has some customers for Nix. The European Space Agency wants it to return cargo from the International Space Station in 2028, and VAST has contracted the company for a cargo mission to the Haven 2 space station that same year. Apparently, we might see humans fly on Nix at some point, but that's not really a surprise. The Exploration Company has been talking about launching crew pretty much since day one, but this is the first time that we've actually seen plans on how to get it done. Reportedly, the capsule can accommodate 4 or 5 astronauts. The company expects that it'll take 10 years to develop and cost about 1 billion euros, so they're banking on ESA to support their plans. But the Exploration Company isn't the only European company with human spaceflight ambitions. The Spanish company PLD Space is planning a crew capsule named Elytra. Alex and Dee discussed these plans with PLD CEO and co-founder Raul Torres on our Europe's Future in Space series. If you watch that episode, you'll know that PLD plans to launch its reusable Mengzhou 5 rocket from Europe's spaceport in French Guiana, and that launch has just gotten a bit closer. At the Paris Air Show this week, PLD and the French space agency CNES signed a contract for the development of these facilities. PLD's pad will rise at the former launch site of the Diamant rocket. CNES is now transforming the area into a multi-user launch complex with shared facilities for up to 5 launch providers, and with this contract, PLD becomes the first company to use it. Construction begins at the start of the dry season, this summer, and the first Mengzhou 5 is expected to lift off from the complex next year. While private space companies such as PLD are working on reusable rockets, the European Space Agency is also working on reusable rockets of its own. Specifically, the Themis rocket, which aims to develop a prototype for a reusable first stage to demonstrate low-cost recovery and reuse technologies. Themis is built from stainless steel and is designed with features that we know from other reusable rocket concepts: grid fins and landing legs. It'll also be powered by the Prometheus engine, which runs on liquid methane and liquid oxygen, or methalox. The vehicle that will fly the program's first hop is now ready to leave the factory of prime contractor ArianeGroup in Les Mureaux, France. From there, it'll move to northern Sweden, where it'll be tested at the S-Range spaceport, and we might even see Themis hop as high as 20 kilometers. The first of these hops is scheduled for the end of this year, but we've also heard rumors that it might slip to next year. Regardless, this is really cool. The European space industry has been hesitant about reusability for a very, very long time, and it seems that we're finally close to seeing some action in Europe. And if you want to stay up to date with news like this, you know what to do. Subscribe to our channel. And if you like our space news coverage, like the video and share it with other space enthusiasts. And there are even more exciting reusability tests coming up in Europe, as the French space agency CNES has contracted ArianeGroup for its Astra program. That's short for Advanced Staged Combustion Technologies for Reusable Engines, and as you might guess, the goal is to develop a new engine. Specifically, the engine must deliver very high thrust, between 2,000 and 3,000 kilonewton. That's similar to SpaceX's Raptor and twice as powerful as the Vulcain 2.1 engine that powers Ariane 6. What's more, it has to use methalox for its propellant and run on the full flow staged combustion cycle. In other words, CNES wants a Raptor. This would be the first European engine to use the full flow staged combustion cycle. Only a few of these engines have been developed, and Raptor is the first and so far only of these to have flown. ArianeGroup has already started production on the first of 2 demonstrators for the Astra program, and the first tests are scheduled for next year. And now for some European news about Blue Origin. The company signed a memorandum of understanding with the European Space Agency and Thales Alenia Space to collaborate on Blue's orbital reef space station. Together, these parties want to explore sending European payloads and astronauts to orbital reef. So why is Thales Alenia involved with this? Well, they also want to collaborate on, quote, supply modules, vehicles, systems, subsystems, and equipment to orbital reef. And Thales Alenia Space happens to be a big player in space stations. The company has built modules for the ISS and is now working on the Lunar Gateway and Axiom space station. So it's no surprise that Blue also might want to do business with this Italian company. But they're also considering the use of future European cargo and crew transportation services. Which services these might be are still unclear, but the capsules that we discussed earlier might play a role. Later in the week, Blue announced it's opening an office in Luxembourg, where it plans to manage its European supply chain. So this could really be the start of an extensive international collaboration. And wrapping up this series of European stories, ESA created an eclipse in space using the 2 spacecraft of the Proba 3 mission. The satellites flew information, separated by 150 meters, and maintained their positions to a single millimeter. In doing so, one spacecraft managed to perfectly block out the sun so the other could take pictures of the solar corona. Now, this isn't the first time that 2 independent spacecraft managed to accomplish this. During the Apollo-Soyuz mission in the 1970s, the Apollo spacecraft created an artificial eclipse for the cosmonauts in the Soyuz capsule, but their pictures weren't great and they were ruined by light scattered through clouds of gas from the thrusters on the Apollo spacecraft. Proba 3 didn't have this issue and returned perfect pictures. But why go through all this hassle just to get these pictures? Well, traditionally, the solar corona is photographed using a coronagraph on a telescope. This instrument blocks out intense sunlight so that the faint corona can be imaged, but the close distance to the sensor means that it has to block out a much greater area to get a good picture. Proba 3 is able to image the corona much closer to the sun's surface, and once everything is dialed in, it should even be able to do that for up to 6 hours every orbit. What's more, the main purpose of this mission is actually to demonstrate technology for precise formation flying. These nice images are just a byproduct, but a very cool byproduct, and with scientific use too. Now let's take a look at some other stories across space, starting with Firefly Aerospace. The company, just a few months after its highly successful Blue Ghost 1 lunar landing, is now offering commercial imaging services of the moon from lunar orbit. This service, known as Ocula, is being offered as several imaging instruments aboard the company's upcoming Elytra spacecraft and mission bus. Commercial imaging of Earth has been available for decades, but this will likely be the very first commercial imaging service for the moon. Elytra Dark, which will start flying to the moon as part of the Blue Ghost 2 mission in 2026, will orbit at an altitude of 50 kilometers and use cameras with a resolution of 20 centimeters per pixel, much better than the 50 centimeters per pixel of NASA's Lunar Reconnaissance Orbiter, which first entered lunar orbit in 2009. Lawrence Livermore National Laboratory is providing telescopes with ultraviolet and visible sensors for the spacecraft, and commercial applications include identifying minerals and space domain awareness, including imaging other spacecraft in lunar orbit. The first Elytra Dark mission to the moon and its Ocula service is expected to last for 5 years. Speaking of Firefly, their upcoming Eclipse rocket is well on its way to its first flight in 2026. Firefly publicly released images for the first stage of Eclipse this week in photos showing technicians performing fit checks of the stage's 2 propellant tanks, one for RP-1 kerosene and the other for liquid oxygen. These tanks store the propellant for Eclipse's 7 Miranda engines. Once the fit checks are complete, Firefly will send the first stage to a test stand before finishing its final integration and shipment to Wallops Island for launch. Although the first flight of Eclipse is slated for no earlier than 2026, this progress puts the company on a good path to that debut flight next year. From Texas and Virginia, we go to the Space Coast of Florida, where this week, the U.S. Air Force's 1st Air Force Detachment 3, or Det 3, rescue team conducted an ascent emergency rescue scenario off of Cape Canaveral with a mock-up Orion capsule. The Det 3 team is the lead unit in the Department of Defense in rescue and recovery operations for crewed flights. It's trained to assist astronauts during a launch emergency and has been in operation for decades. Should anything go wrong with a crewed launch during ascent, Det 3 will be ready to conduct rescues off the Cape. Capsules like Orion, Crew Dragon, or Starliner are equipped with abort engines that are designed to pull the spacecraft away from a falling rocket during ascent, and the testing in this case took place with Orion ahead of Artemis 2. Once pulled out of the failed rocket, the capsule descends on its parachutes to a water landing somewhere in the ascent corridor. Det 3 then heads to the scene with helicopters and rescue units. Let's all hope that they're never needed for real. Varda Space, a startup company that's already flown 3 missions with its Winnebago spacecraft, is preparing its W4 mission for flight on the upcoming Transporter 14 launch. To that end, the company became the first to receive a Part 450 reentry license from the FAA, meaning they now have unlimited reentries and don't need to license each individual mission as long as they fly the same mission profile. The license is good for 5 years, and all FAA risk and safety requirements still need to be met. Varda's Winnebago, not to be confused with the one in Spaceballs, is a space factory that can build things that are difficult or impossible to make here on Earth. The company's primary landing site is now at the Kuniba Test Range in southern Australia, though its first mission landed at the Dugway Test Range in Utah. W4 is the first Winnebago spacecraft to be built entirely in-house. The first 3 spacecraft's buses were built by Rocket Lab, and this one uses a version of the Pika heat shield used by spacecraft like the Crew Dragon. Now let's take a look at the space traffic of the week and see what's coming up next week in spaceflight. This has been a rather quiet week for launches, and it all started with 2 Starlink launches, one from Vandenberg and the other from Florida. Both were successful and delivered an extra 54 Starlink V2 mini satellites into orbit. With those, SpaceX has now launched just over 9,000 of these since 2019. Those 2 launches were then followed by a rather secretive mission this week. The mission in question was the first operational launch of the Angara rocket in its most powerful configuration, with liftoff taking place on June 19th at 3 o'clock UTC from Plesetsk. The rocket was carrying a classified payload for the Russian Ministry of Defense into a geosynchronous transfer orbit. Unfortunately, since it's classified, very little is known about it. And right at the end of the week, we also had a Chinese launch from Xichang sneaking in as usual. Going into next week, in addition to the usual set of Starlink launches, we'll have some pretty major missions on the calendar. One of them will be the 33rd launch of Blue Origin's New Shepard rocket, carrying 6 passengers up to the edge of space. It's interesting because Blue just did a New Shepard launch with people on board barely a month ago, so it seems the company is slowly building up a launch cadence with New Shepard. Next week, we're also expecting the launch of a Falcon 9 with SpaceX's Transporter 14 mission, the 14th mission to sun-synchronous orbit under the company's small-sat rideshare program. By the way, this is the one that includes Varda's Winnebago 4 spacecraft and the capsule for the exploration company's Mission Possible test. Now, you might have noticed that we didn't cover 2 launches in particular this week, and that's because they didn't happen. If you watched last week's Space Traffic Report, we talked about how the Axiom 4 mission on SpaceX's Falcon 9 rocket might have had a chance to launch this week after having suffered delays from 2 different sources: issues with the rocket itself and with the International Space Station. Well, over the past week, it seems like teams decided to take just a little bit more time to understand the situation on the station and the existence of those air leaks on the Zvezda service module. The launch had been rescheduled at one point for June 19th, and then later moved to June 22nd, but those 2 dates are pretty much out of the question now. It's currently still unknown whether the mission will be able to proceed in the next week or so. The other launch that didn't happen was the launch of the second batch of operational Kuiper satellites on ULA's Atlas V rocket. The rocket was rolled out to the pad, the countdown was started, and the propellant load was well underway when the company decided to scrub the launch. According to ULA CEO Tori Bruno, the culprit of the scrub was an issue with a gaseous nitrogen purge line that couldn't be resolved during the short 30-minute window for this launch. Since then, Atlas V has been rolled back to the vertical assembly facility for vehicle checks and to fix the issue. The company is now tentatively aiming for a launch on June 23rd at 10:54 UTC. And that's your weekly update of spaceflight news. I'm Alicia Siegel for NSF, and we'll see you all again next week to recap this week in spaceflight.